You're about to fall into a black hole. Not metaphorically, for the next few minutes, imagine every second of it actually happening to you. By the end of this video, you'll know exactly what happens to your body, second by second, from the moment you spot it in the distance to the moment you disappear from the universe forever. Most people think it would be instant. It isn't. And the truth is stranger, and slower, than almost anyone expects. At first, you don't see the black hole at all, you see what surrounds it. A swirling disk of superheated gas, called the accretion disk, spins so fast it glows brighter than entire star systems. That light is the last warning sign you'll get. Somewhere inside that glow is the thing itself, a region so dense that not even light can climb back out of it. And you're heading straight for it. But brightness isn't the danger. The danger is what happens as you get closer. As you approach, space itself starts to bend. Light from the stars behind the black hole curves around it, an effect called gravitational lensing, warping the sky ahead of you into rings and streaks of distorted starlight. It's beautiful. It's also your last clue that gravity here doesn't play by the rules anymore. The closer you get, the less space and time mean what they used to. But the real danger isn't what you see. It's what gravity is about to do to your body. Gravity doesn't pull you evenly. It pulls harder on whatever part of you is closest to the black hole, and weaker on whatever's farthest, and near a small enough black hole, that difference becomes extreme, stretching you feet first into a thin, impossibly long thread. Scientists actually call this spaghettification, and it's not an exaggeration. But here's the twist almost nobody knows: near a large enough black hole, that stretching happens so gradually that you could cross the point of no return feeling completely, deceptively normal. That point of no return is called the event horizon, and here's the strangest part: you wouldn't feel yourself cross it. There's no wall, no flash, no signal of any kind. One moment you're falling freely through space, the next, you've silently passed the one boundary in the universe that nothing, not light, not information, not you, can ever cross back over. From here, everything you knew about escaping is already over. What happens next depends on something scientists still can't fully answer. Beyond the horizon, general relativity predicts you'd keep falling toward a singularity, a point where gravity becomes infinite and the equations simply break down. But predicts is the key word. No signal can ever leave the event horizon to confirm what's really happening inside, so nobody, not one physicist on Earth, actually knows what you would experience in those final moments. It's one of the last true blind spots in physics. Meanwhile, something very different would be happening to anyone watching you from a safe distance. To them, you never actually fall in. As you approach the horizon, time itself would appear to slow down from their point of view, stretching your final moments longer and longer, your image growing dimmer and redder, until you seem to freeze at the edge forever. It's called gravitational time dilation, and it's been measured, confirmed, and built into technology like GPS satellites. So somewhere, in a sense, a version of you is still falling. And that split between what you'd experience and what they'd see is where this gets genuinely strange. So what really happens if you fall into a black hole? You'd stretch, you'd cross a boundary you'd never feel, and you'd vanish from the observable universe while somehow, to everyone else, never quite disappearing at all. That's the part science can prove. What waits beyond the horizon itself remains one of the biggest open questions left in physics. And maybe that's the most unsettling part: somewhere out there, a black hole is holding the answer, and it's never going to tell us.